do this, but we do have the technology to do it remotely here, so that's good. So it's not as good as in person, but we'll get right to it. And so Gay has been also working feverishly to get you involved here, and so at some point here we'll get some polling involved here too. So
well, would you like to start off with that, just to see what people kind of generally think about what lies ahead?
You bet. Let's start with a poll, and then we'll have another one later in the program.
Okay, so if you're a viewer, hopefully you can see this poll. You can click on what you think will be happening in the future for us, and we'll share the results. I'm going to talk for about, oh gosh, another couple of seconds. People are voting in, so get your votes in. Not everybody's typed in anything. Very interesting. Okay, and then I'm going to turn around and share these results, and then we'll let Rick continue. We'll have a few of these. See what you think. Okay, the polling's ended. I hope you can see the results. Only one, hot as Hades, and I didn't vote. So there you go, Rick. Thank you.
All right. Well, so that's quite interesting, and so we'll see how how your thoughts comport with the experts as we get towards the later part of this program. All right, let's see if we can make the technology work here. Oops. All right, here's what we're going to do, and hopefully my slide advanced.
Yes, it did.
All right, so this evening, the last one of these straight science that I did was back at the end of October. So we're going to kind of review how things have worked out with a focus on Western Alaska for the 2019-20 winter season and spring so far. And an important thing that I want to do, and we always should do, is, okay, well, we got these outlooks of various things. Well, how well did they actually perform? So we'll take a brief look at kind of basically what I showed in October. How did that actually work out? And then the third part of the program this evening is the outlook for the coming season. So just some highlights from November through May. First of all, might be hard to remember, but snow came really late to most of the region. Had put together this composite here of webcam images from November 17th, and almost everywhere in Western Alaska, with the exception of Shishmaref, which I don't have on here, still had no snow on the ground past the middle of November. Now, some places did have snow late in October, but remember we had that big rainstorm and washed it all away. And so we started off very late establishment of the snow cover and generally mild conditions, not unbroken mild, but generally mild for November and into December. About the middle of December did turn colder, and then for most, again, not unbroken, but most of January and February into the first part of March were cold, not record cold, but certainly colder than we've had, and certainly sustained colder than for a few years. Turn towards storminess and milder weather mid-March and April. Again, nothing terribly unusual for Western Alaska, but a big change from earlier in the winter. And then so far this month, with the exception of St. Lawrence Island and the Bering Strait proper, this month has been extremely mild, and Noaa is going to make a run at the warmest May of record. So really quite a varied temperature regime and snow regime for the region over the last 6 months. All right, so I wanted to walk through, these are monthly temperature departures, and this is using basically as much of the Weather Service and for Western Alaska, importantly, the Weather Bureau, the FAA stations at airstrips that report. If we can get basically a month's worth of reports without too much missing data, we can generate monthly departures. November on the left-hand side here, you can see nothing but positive numbers across Western Alaska there. Notice 8 degrees above normal at Gamble, more than 7 degrees above normal at Point O, reflecting very low sea ice and those warm sea surface temperatures that we had last summer and into the fall. December in the middle panel started to cool off. Again, this is really kind of the average of the 2 halves of December, mild early, colder late. Most places it came out close to 0 overall, but again, notice out on St. Lawrence Island, because the sea ice didn't show up till right before New Year's, much above normal. And then January on the right-hand side there, generally colder than normal everywhere there, although for the Seward Peninsula and St. Lawrence Island, Bering Strait region, not dramatically cold. Notice those numbers in southwest Alaska, 18 degrees below normal. For the month as a whole at King Salmon, 14 at Dillingham, 19 degrees below normal for the month at Kaliganuk, but nothing quite that cold in the Western Alaska. Notice though, there is a west to east gradient. Savunga was not very much below normal, less than a degree below normal, but over 9 degrees below normal at Unacleat for January. Moving ahead now to February on the left-hand side, this was really the heart of the cold month, coldest calendar month for Western Alaska. A lot of big negative numbers there, and you can see 8, 9, 10, even 12 degrees below normal. That's pretty significant. But big turnaround in March in the middle, and look at those numbers at Gamble and at Wales there, more than 12 degrees above normal. That is really quite remarkable. Not to the level of last March, but that's really warm. And then April, of course, also another very mild month all across Western Alaska. So again, illustrating that flip-flop in temperatures that we've all experienced. So I had this idea, okay, so we did have a period of extended cold weather. Well, how does this rank overall? How do we put this in context? So what I did is I found the coldest 90 days in each winter since 1931, when the Weather Bureau office opened in Nome. And so then I just ranked them, and the big fat red one there circled, that was this year. And to help you get a sense of where this ranks overall over the last 90 years, this was the 17th coldest 90-day period. So if you want to call that kind of the heart of winter, this was the 17th coldest. Okay, so that's not record, but you know, that's 17 out of 90. That's not too bad. But in yellow there, I've shaded years that have occurred in the past 30 years. And you can see that while over the long term, this maybe isn't so exciting, this was the 4th coldest winter, the core of the coldest weather, 4th coldest in the past 30 years. Okay, so that's non-trivial, right? Yeah, sure, it's been colder, and it's been 1971, a lot colder, but for the recent past, this was quite notable. All right, Bering Sea ice, of course, always in the news. This is updated through yesterday. And on this, the thick blue line is just as the horizontal sea ice extent. The thick blue line is this past winter. The green and red dash lines are the last 2 years. And there's a lot of interesting things going on in this, so I'll just take a minute to go through this for this year. First of all, in November into December, that blue line is very low. In fact, at one point we were, I think for a couple of days, actually at the lowest sea ice extent of record there in the Bering Sea in mid-December. And most of December until about Christmas was exceptionally low. Then with the turn to colder weather, we saw that sea ice extent expand. And by the time we got up to about the 10th of January, it was getting close to normal, that thick black line. But then we had a couple of storms come along, and the sea ice extent wound up falling by almost 20% from 2 storms. And that is reflecting the fact that, yeah, the ice extent increased, but it was all very thin ice. And so a couple of run-of-the-mill storms come along and chew up that new thin ice. Just had a couple of those, then the colder weather returned, sea ice increased, and we did wind up from about mid-February to about the 14th of March, was actually near to even a little bit above the long-term normal. But then, just like we saw in January, but this time more extreme, dramatic drop in the sea ice, the second half of March there. That's actually the largest fall at that time of year, both as a percentage of area and in absolute terms. And that occurred, of course, at the time of year when on average, the ice is reaching its maximum extent. And once again, the March time frame, the late March time frame was stormier, but again, than it was in January, but it was working on very thin ice, very thin ice. So it was stormier than just a couple of storms in January, but it was nothing particularly unusual for Western Alaska and for the Bering Sea, and it really did a number on the sea ice. Now, during April, the decline was relatively modest, and that I think is also reflecting what we saw this past winter, where we chewed up that really thin ice out in the central Bering Sea pretty easily in those storms in March. But closer to the Alaska coast, as we'll see, and as you lived, the sea ice had formed. Once it got going, it was able to thicken up, and with this colder weather that we had from mid-December into March, was able to thicken up, more stable, and so it took more to get that ice to melt. But now, of course, we're well on the way to melt out. So just again, a brief 1 month apart here, images of sea ice from the National Weather Service Sea Ice program, the concentration analysis here. And mid-November on the left-hand side here, tremendous amount of open water into the northern Chukchi Sea yet. Ice, though, starting to form November 15th along the Alaska coast, mostly near the outflows of the rivers at November 15th. Significant expansion there, December 15th, with most of Norton Sound becoming iced over. Recall that that took a long time to get to Nome, though. Was it the last day of November, 28th or 9th of November, Gay, that had ship unloading passengers at the Port of Nome?
Yeah, thanks, Rick. The Port of Nome was operational 27th of November. That was a record breaker there.
Yeah, so really quite remarkable. Then moving into December, we see that sea ice expanding. Finally now, the ice got to St. Lawrence Island from the north just before New Year's, and continued to expand nicely into December, or into January. February 15th there, we got the ice past St. Matthew Island. Non-trivial amount of ice in Bristol Bay, at least compared to the last few years. March 15th, this was just about at the start of the big decline. And then April 15th, basically showing where we wound up with the ice pushed way back north of St. Matthew, still lingering there in Bristol Bay. So next slide here is a couple of notable sea ice dates here. We had the third latest freeze up of the Chukchi Sea. This was about it. December 21st, Chukchi Sea became about 95% ice extent, covering 95% of the basin. That's the third latest of record. And guess what? The three latest years of record are 2017, 18, and 19. And then on the right-hand side, just to show you there, about March 5th was the maximum sea ice extent. You can see ice just touching St. Paul there. St. Paul had ice for about 3 days, much less than the historical normal, but at least they had some this year, but only for a very short time. And ice expanded down a little bit farther down the Alaska Peninsula there than we've seen in most recent years. So, and then the other thing to call your attention to on that maximum ice extent is the gray shading along much of the coast. That indicates fast ice, and that's maybe a big change from what we've seen the last couple of years. Much more fast ice, stable ice than we had in 2017, 18, and 18 and 19. So that's a big deal, of course, for activities on the ice during the late winter. As I mentioned, here's the plot there of the Chukchi Sea ice over, continuing this really dramatic trend for much later ice over. And this, of course, is important for the Bering Sea, Bering Strait region, Seward Peninsula, because until the Chukchi Sea ice is over, we can't really get that ice down through the Bering Strait and into the central Bering Sea. We can grow ice out from the Alaska coast and the Chukotka coast as well, but getting that ice down to St. Lawrence Island requires the Chukchi Sea to ice over. And you can see there the trend 3 weeks later here, just since the early 1990s. That is really, really dramatic. Here's just a plot of the daily temperatures, departures from normal at Nome since November 1st. And unlike some of these that I've shown in the past here, it's not just a solid red there. Although 56% of the days were warmer than normal, and 44 below, but that's not, that's kind of the way that was perfectly normal in the sense that over a 6-month period, that will happen sometimes, unlike some of these that I've showed that have been, 80% or more above normal over a multi-month period. Overall, the average day was about just over ½ a degree above normal. But again, that cold, quite concentrated there from mid-December to the second week in March, but not unbroken there. You can see that stormy period there in January that chewed up a whole bunch of ice, and then a couple of warm intrusions, and that had some snow as well there in February as well. All right, this was hot off the press yesterday. One of the big features the last few years has been really excessively warm sea surface temperatures, fueled by that very early ice melt, allowing the sun to start heating the water far, far earlier than historically normal. This year, not so much. This is from the Noaa high resolution sea surface temperature data set. And so this is for a point about 30 miles south of Nome. I call it my Western Norton Sound point. And the green line, if you look at the bottom left there, that's this year up through a few days ago. And you can see, actually it's below the normal. Wouldn't get too hung up on that. There was a change to to this database here this year, earlier this year. And one of the things that got changed was how they estimate sea surface temperatures in areas with moderate ice concentrations, which this area south of Noma's had until very recently. So I wouldn't get too hung up that it's well below normal, but there's no doubt about we are nowhere near where we were last year at this time, which was near or above or at record levels. So we'll see how this changes here as the last of the ice melts out and we get into the peak heating season here. But clearly, much different scenario than we saw last year or in 2018. All right, so that's kind of where we've been. How about the outlooks from the autumn? How did they work out? Well, you kind of know how they worked out. This is a graphic here that I actually showed in October, and between the black triangles there, that was from the October forecast from the Climate Prediction Center. That was the 50% band. They had a 50% chance that the actual temperature would fall between those black triangles, and the 2018-19 are the red dots. And so I just added to this those kind of blue rectangles there. That's what actually happened. And you can see that we actually, for December, January, February, and January, February, March, we actually fell below the bottom triangle there, so below the 50% mark, pretty much right on it for February, March, April, inside it for the spring here. A few days to go, we'll be in it. It will be interesting to see for the last part there, April, May, June, with April and May being quite warm. Odds favor that we're going to be above that triangle, the upper triangle there. So all in all, maybe not the best performance by the Climate Prediction Center. Another tool that I showed in October, this is of my own devising. I'm quite interested in how this Bering Sea summer temperatures impact sea ice. Part of the reason I'm interested in this is because back in the day, we never really thought about what Bering Sea temperatures were, that the Bering Sea ice cover would depend on what the weather is during the winter. But then again, we weren't dealing with the kinds of summer sea surface temperatures that we have now. And so I came up with this plot here, and the dashed line is the estimate of what is just the fit there of what the February, March average sea ice extent would be based on the late summer sea surface temperatures. And so 2019, we knew in the fall what the July, August, September sea surface temperature was. The average temperature for the northern Bering Sea was over 52 degrees Fahrenheit, and that is the warmest in the last almost 50 years here. And so my little regression here predicted a median sea ice extent of about 475,000 square kilometers for February, March, and we wound up just under 800,000. So that didn't work out so well. That's actually not surprising, right? We know that sea surface temperatures are only one piece of our puzzle here. And we wound up, as you saw, with a significantly cold winter. So between that was able to offset to some extent the warm ocean temperatures. But again, what we had here for 2019, for 2020 was not, was not above normal. And had this occurred with colder sea surface temperatures, we'd have had ice earlier in the season. Undoubtedly, we would have had a lot more ice in the late winter and spring in the Bering Sea. All right. Here's this is the NOAA experimental sea ice concentration outlook that I presented to you in October. This was a forecast that was made in late September. And this was the 20 different models going into this experimental sea ice prediction, and this was the outlook for, this was the average concentration for the entire month of March, not any specific date, from that model. And so my memory is that we remarked that this seemed pretty darn low, but given our experience, we couldn't really write it off. So particularly the area of, less than 50% ice there, all the way up to north of St. Lawrence Island. That was like, that would be something, and that had us worried. So how did this work out? This was the forecast, the average from 20 different models. And here's what actually happened. And you can see if I toggle back and forth there, all in all, probably not a good forecast. Way more ice, and way more ice in most areas, both in the northern Bering Sea and along the Alaska coast, all the way down to Bristol Bay. So that's why it's an experimental model. Still plenty of tweaks to do with that. So that one didn't work out. Maybe the way that we would have liked. And then just the big picture here and I could go through many iterations of this, but that would be very boring. So for November, December, January, the color field here is what the Climate Prediction Center, NOAA's primary center for forecasts for from about 2 weeks out to about a year. And this was the forecast that was made in October for November, December, January. The red colors, the warm colors indicate a tilt towards significantly above normal. And the shapes indicate what actually happened, representing the long-term climate sites that we have use of. And so for this, you can see all of Alaska favored significantly above normal, and the darker red colors over western Alaska, as well as Northwest Arctic and the North Slope, had higher chances. And in fact, for November, December, January, that did not work out that well, except for St. Lawrence Island, where, because of the late ice arrival, the colder weather in January wasn't enough to offset November and December. For the Seward Peninsula, again, that switch in mid-December, basically, it all came out in the wash, so we wound up with near normal. So all in all, not that good of a forecast for Western Alaska from the Climate Prediction Center for the early winter season. Precipitation, that's a tough one, of course, because we don't have much in the way of reliable precipitation measurements anywhere in Western Alaska during the winter these days. Hopefully that will be changing, at least hopefully at Nome anyway. But such as we have, and also using other tools that we have at our disposal, like modeled precipitation, pretty sure that over most of Western Alaska, it was a fairly, it was dry, significantly drier than normal during the early winter. Confidence of that is low, and we do know that not that far away, November, December, January was extremely wet. For instance, near record precipitation at McGrath. So there was a sharp dividing line in there somewhere, but I don't think it was to be found in Western Alaska. More likely maybe something like Chivak or Scammon Bay up towards Galena line. Now for the early spring season, so February, March, April, same idea here. Very strong tilt towards warmth across most of the Seward Peninsula, Bering Strait region. Odds highest kind of over the Seward Peninsula, slightly lower odds for significantly warmer than normal over eastern Norton Sound. And again, this one, February was cold enough to basically balance out the milder weather in March and April. So near normal wound up verifying at Nome. Again, a gamble wound up with that, especially that very warm March, and probably in the Bering Strait too, wound up significantly warmer than normal. But again, all in all, not a good forecast from the Climate Prediction Center, but not as bad over Western Alaska as it was over a large chunk of the interior and South Central, where most places wound up colder than normal in contrast to the forecast, which was for warmer. Precipitation, on the other hand, did work out. Pretty good confidence that precipitation was significantly above normal across Western Alaska during the early spring season, February, March, April, and that a lot of that fueled, of course, by the mild stormy weather in March and into, at some extent, into early April. So that was a pretty good forecast there. So that's kind of a quick review of how things have gone. And Gay, did you want to do the second poll now, or did you want to wait to the end?
No, we can launch. Here we go. If everybody's ready, this is from Rick Thoman right before we started. When you think about what normal weather is, are you thinking about what the weather was last year, the past few years, when you were young, or what you heard from your parents or grandparents? Fire away. And we've got people are voting in. And I hope, at the end we'll have questions for Rick. I know I've got some, and I'm looking forward to this next portion, the outlook portion, the crystal ball. And I think it's really upfront, Rick, the way you sort of say what you said and then how it panned out. Not a lot of people do that, so it's very interesting and informative.
No, that's really important in this business, not just to throw forecasts out there and then forget about them. Knowing how they do helps folks learn how to use this information most effectively. It's just a tool, and we want to be able to use it intelligently.
All right, so here are the results. Most everyone voted. Not. Can you see that, Rick?
I can.
People... Okay.
So a strong winner there with when we were young is what the normal is.
For me, that seems to be most memorable. I'm kind of losing. All right, so thank you, everybody, and we'll let Rick continue.
All right. So this part is last part here is kind of is what do the tools show for this upcoming summer, given where we're at now with the climate system, where we're at with sea ice, where we're at with ocean temperatures, and the computer modeling that's available. What do we look for this summer? All right. Is that yeah, there we go. Okay, so I thought I'd start out here with sea surface temperatures. So I'm always looking to get this data in a way that I can show it that's most useful for Alaska. And I've been trying to find this sea surface temperature information, and I think I finally did. So this is the forecast for this coming July, August, September. So kind of that's the ocean's midsummer, if you will. And what this is plotting is the chances that the average sea surface temperature for this 3-month period will be significantly warmer than normal. Not just a little bit above normal, but significantly, upper third. And this is quite interesting. First of all, notice over most of the Bering Sea, we have a 50 to better than 60% chance with that the average sea surface temperatures will be significantly warmer than normal. The areas close to the coast, though, the models are not as strongly indicating that, with a less than 50% chance of significantly above normal. Up in the north, in the Chukchi Sea, the odds increase again. So this is kind of interesting. I'd be curious to see what this looked like last year. I suspect that it would have been higher, but I think the important takeaway here for folks on this call is that out in the open ocean, where these models are going to do the best, the Bering Sea temperatures are very strongly indicated to be significantly warmer than normal, and it won't take much to push that to the coast. The other interesting thing, of course, in this view, is that you can see that most of the North Pacific has a strong chance of being significantly warmer than normal. Now here is the Rick Thoman contribution to this forecast. So we have had a really warm April. May is threatening to be record warm. So it occurred to me, can we use, what does a warm spring tell us about the coming summer? What, if anything, does it tell us? And so using the 113 years of priceless known climate data, I came up with this little plot, and basically I've just plotted the departures from average during the spring, that's on the horizontal axis, and then the following summer's departures from normal, that's on the horizontal axis. When we do this, we wind up with 4 different categories. So in the upper left, we have, it was a cold spring, but then that was followed by a warm summer. In the bottom left is cold spring, and then the subsequent summer was cold. On the top right, that is a mild spring, followed by a warm summer, and then the bottom right is, it was a mild spring, but summer disappointed and wound up being cooler than average. And the green line is just the regression through that. So does this tell us anything that we can use this year? Well, I think so. For April and May this year, we're going to be at about +6 for April, May. So if you go over on your horizontal line there and go over to 6 and then go straight up, you'll see that virtually every summer that has followed a spring that was 6 or more degrees warmer than normal also was warmer than normal. There's a couple there just below 0 that what the springs were maybe like 5.5 degrees above normal that wound up just a little below normal for the summer. But this suggests that given our very warm spring, we have definitely tilted the odds towards having a warmer than average summer season. That makes, of course, reasonable physical sense. Very warm springs are going to, especially as warm as they are now, that almost surely means less sea ice than the long-term average. And often sea surface temperatures are going to be warmer than normal as well, or at least we're going to get an early start on that. So it's not particularly surprising that the warmest springs very strongly tilt the odds to warmer summers. Here's the Climate Prediction Center's forecast. These just came out last week. And from these, you can see this is for June. All of Alaska is favored to be significantly warmer than normal. For Western Alaska, it's not quite up to a better than 50-50 chance for significantly warmer than normal, but it's well up there. If this is an unbiased forecast, it's about twice as likely in June to be significantly warmer than average than cooler than average. Precipitation, really no tilt at all in June. For the Seward Peninsula, St. Lawrence Island, and the Bering Strait, June precipitation-wise is actually more like spring months. We don't really ramp up to the wet season until we get into July climatologically. And really wet Junes are actually fairly unusual. For the summer season as a whole, again, just released from the Climate Prediction Center last week, the chances actually increase. Notice Eastern Norton Sound and Southern Norton Sound, better than 50% chance of significantly warmer than normals. Those areas, the chances that it will wind up for the 3-month period being significantly warmer than normal is almost 3 times the chances it would be significantly colder than normal. Chances edge up as well for St. Lawrence Island and the Bering Strait coast. Precipitation, different story than in June, with a tilt towards wetter than normal for the 3-month period. And that would imply that we would see a more than the usual increase in storminess in the later part of summer. Again, to get the precipitation above normal, and we're back end loaded anyway, suggests that we would see more storms than average, or at least they would produce more rain. I guess it doesn't really tell us anything about the number of storms, but the amount of rain that we would get from those storms would go up. And that's, again, if we wind up with Bering Sea temperatures significantly above normal, that of course loads the dice to provide more moisture to the atmosphere. In October, there was a question about wildfires on the Seward Peninsula, and that's not surprising. We had smoke over much of the region for a few days last year, and it turned out that 2020 burned more than 120,000 acres on the Seward Peninsula. The Seward Peninsula as defined by the Alaska Fire Service, and that was actually the most acreage burned on the Seward Peninsula since 1977. And it pales in comparison to that year, which had a couple of huge fires, and there's also a couple of years earlier than that that had some big fires as well. So I thought I would just take this opportunity to address that. And actually I went through the Alaska Fire Service database, and I went ahead and annotated, and this is probably about as most comprehensive mapping of Seward Peninsula fires that we have. If you look there, you can see several big fires there. The Kugruk and the Granite Mountain fires in 1977 that contributed to that almost 800,000 acres. The fires there in the Amuric Basin in 1954 and again in 1971, those are really quite interesting to me. And who remembers the 1990 Sledge Island fire? I actually, when I saw that, it's like, oh yeah, I remember that. It was, wasn't a big fire, but it's like, wow, you could get a wildfire on Sledge Island. Who would have thought? So there you go. Anyway, so I thought this was pretty cool. So just to wrap it up, so what's coming up? Warmer than the long-term normal is likely, not certain, of course, but odds definitely favor warmer than the long-term normal. And so this would be a good time to, okay, so the strong majority of the folks that voted just thought that normal was something like when they were young. And depending on your age, that works very well with how the Western science defines normal. For most purposes that we work with, 30 years is the normal, and right now 1981 to 2010 is the normal period. So if you were young in that period, then you're right on. Of course, you'll have to recalibrate next summer when we change to 1990 to 2020. But for now, if you're the right age, you're right in line with the international standard. Ocean temperatures are very unlikely, I think, at this point to wind up as high as they were in 2019. They're still cold in most areas. I think everywhere in the northern Bering Sea, they're colder than last year. And it's already May 28th. Summer solstice is only 4 weeks away now. So we could certainly wind up above normal, but I think we are not it's not in the cards to see a repeat of temperatures as warm as we had in 2019 or 2018. Summer rains, we don't really have anything to tilt the odds from the long-term average. So whatever you remember in your youth has as good a chance as happening as anything else. Wildfires, of course, will be yet to be determined. Wildfires are really strongly conditioned on the weekly to monthly weather. If we get 10 days of hot, sunny, dry weather, followed by some lightning, we could have wildfires. If we don't get those, it doesn't matter if the averages are high, we won't get fires. So that's much more in the luck of the draw type column. So that's what I have for you. If you have any questions, there's my email. I suspect most of the people on this call are already on our Facebook group listed there, but if you're not, feel free to join and post lots of interesting stuff focused on the St. Lawrence Island, Bering Strait, and Seward Peninsula, Norton Sound regions. That's it. Take it away, Gay.
All right, well, thank you so much, Rick. And just so you know, because I know when you're giving these, you don't have time to get into the chat box and have a look, but please know there are people congratulating you for your award-winning career performance for the,
well, thank you all.
the level. So you should go back and check some of those out. And now I guess let's open it up for questions to Rick. Who'd like to ask Rick a question regarding our winter weather or what lies ahead?
I might have one.
Go ahead, Claudia.
Yeah, so I was wondering, some of the predictions that you made last fall didn't quite turn out, right on. And I wonder when that happens, can you in hindsight sort of pinpoint why that was? Like, was there some kind of unexpected weather event or unexpected movement in the atmosphere or whatever that kind of, turn things in a different direction than your models originally predicted? Or
yeah, so that's a great question, Claudia. Thank you. So this winter was really quite interesting. It turns out that Alaska and parts of the Canadian Arctic were about the only places in the entire Arctic that had much of any colder than normal weather. Almost the entire Eurasian continent was excessively warm. Large areas in Russia, especially central Siberia, had either the warmest or second warmest winter of record, and it was almost unbroken warm. Now again, that's relative to normal. It's still Siberia, it's still cold, but not much for what's normal for there, quite warm. So you may have heard about very strong polar vortex this year in the Arctic, and that's very true. And that does explain why places like Washington, D.C. got very little snow, but that doesn't help us to understand why at 65 north in Western Alaska, it was cold in January and February, but at 65 north in central Siberia, it was near record warm. So some of that was undoubtedly luck of the draw. It could be that polar vortex could have been just as strong and oriented a little different so that we would have again been super warm and Siberia would have been a little bit cold. And some of it is, the models did not forecast that persistence of that cold polar vortex nearly to the extent that it occurred. By some measures, it was the strongest in the last or second strongest in the last 70 years. So that's part one of the answer, is just the luck of the draw. The other part is, of course, that many of the climate models, what we wind up latching onto is that long-term signal. And here in Alaska, since 2013, just knowing nothing forecast warm has worked out pretty well most of the time. And but it's not always that way. And in this case, we just missed it. So the long-term signal was not a good forecast for this winter.
All right, yeah, thanks.
Thanks, Rick. Thanks, Claudia. Any other questions for Rick?
Maybe if I can pop in here.
Hi, Jim Massa.
Hi, how you been,
Pop
Gay?
in.
First of all, Rick, appreciate all your excellent work on this. And I guess this is kind of a follow-up to Claudia just brought up. I was just wondering, in looking at all this, if you had examined what the Arctic Oscillation, the Arctic Dipole, how they were controlling or influencing what has been observed.
Yeah, so the Arctic Oscillation Index, of course, was quite high, reflecting that the persistence of that polar vortex this past winter. If you look at the correlation with Alaska temperatures and just the Arctic Oscillation, it's not that there's no correlation, but it's not terribly high. It's actually higher on the North Slope in the summer than it is in the winter. And some of that is just because the trends are so strong in the winter. So that is certainly, that played a role, but I would hesitate to say that if only we would have forecast that the Arctic Oscillation Index, for instance, to be as high as it was, we would have gotten this forecast. I don't think we would have done that.
Thank you.
All right. Thank you, Jim. And thanks, Rick. Anyone else? I did have a question that was sent sort of in this private chat, and I'm going to ask it because it's a good question. Someone's wondering if there's any data about wind and storm comparisons during the winter period. It seems those are big drivers of sea ice and consequently the change of seasons. Any thoughts on wind and storm comparisons?
Wind and storms. Storm tracks and storm counts are incredibly important for Western Alaska, and it is much harder to get to that than you would think it would be. Wind analysis is actually more tractable, and I will dig some of that up and post it to the Facebook page. Overall, though, I think that what we'll see is, yeah, there was a period with more north wind for sure, but again, not dramatic compared to the historic extremes. But we know it's important, and what we would really like is a forecast of that, and at the seasonal level as well as for analysis, and that's forecasting. Storm tracks, unfortunately, are just beyond the edge of what we can do at this point. Wind is again more, that is probably within the realm, but what really matters, of course, is not just wind per se, but a south wind is not the same as a north wind when it comes to sea ice or precipitation. And so just having the wind speeds are not quite as helpful as the directions, and that's where the difficulty comes in.
To what extent does sea ice moderate spring, early summer, and can you track it over time looking at the extent? How does it affect spring and early summer with regards to the maritime weather and coastal weather?
So at the margins, and by that I mean either a lot of spring sea ice or very low sea ice, certainly has a major impact on temperatures and cloudiness, things like that, for the region. It's kind of the in-between states that are harder. So this year is a good example of that. While northern Bering Sea ice is below the historic let's say the 30 year, the ice of your youth. It's of course it's been much more extensive than the last couple of years, but this is already guaranteed to be warmer May than the last 2 years, and it may, and Nome and points east may actually be the warmest May on record. So even though there was more ice, wasn't enough. It's not quite a chicken and an egg situation with air temperature and ice, in the sense that if it's warm, it'll just melt the ice, since much of the melting of the ice, of course, is occurring from the water and less from the air temperature. But at the margins, it makes a big deal. And in part, it's related to the larger scale weather patterns. If you look at some of the highest ice years in known history, so back to the gold rush, for instance, the spring of 1922, that has those pictures of the bear just locked in ice in Nome in June. Those were very cold springs. It was cold in part because the weather pattern was really, really cold. Lots of north wind, very cold air mass. So at the very warmth and the very cold, there is a good correlation. In between, it's much murkier.
All right, thank you, Rick. Did that answer your question, Hector?
Yes, thank you.
All right. I actually have a question, Rick, on the ice, because people are talking about the ice, and I don't know if this is technologically available, but ice thickness. I don't know at some point if there's a way to look at ice thickness from above, if it has the kind of resolution that you would need, but what happened, or what's been happening the last few years is we have this weak ice. And this past year, it looked like we had those cold temperatures and it was rocketing down to the south, but our water temperature was still warm. And there were these reports coming in from people who are ice fishing or crabbing under the ice that the water temperature was, may have been eating the ice from below. I don't know if there's a way technologically, can they look at ice thickness when they're describing the extent and make some sort of prediction about how fast it might go away? Is that something that's being done or possible?
So there are estimates of sea ice thickness from satellite. For Western Alaska, the problem is that the error bars on those thicknesses are generally as large or larger than the ice thickness. Those
Right.
the satellite estimates of thickness are much more reliable, say, off the North Slope coast, where the ice is much thicker. So there are estimates, but the validity of them or the usefulness of them, as I posted on the Facebook group occasionally, they're probably good for comparative. So for instance, at some point this winter, I posted one and you could see thicker ice packed up on the north side of St. Lawrence Island due to the north winds. So for comparative purposes, it's probably okay. For absolute values, probably not. What is going on in the sea ice forecasting world and the computer modeling is they're attempting to model that thickness based on the physics. And that's certainly a valid approach. But again, for our part of the world, the error bars around that are close to or exceed the actual ice thickness for much of the year. And especially when it's really thin, when it's most vulnerable, that's when both the satellite observations and the modeling is least reliable. So we kind of got a catch-22 there.
Right.
But these things are always improving. You know, the fact that we can even make even vaguely reasonable estimates of sea ice that's, you know, inches thick now, you know, is something that we wouldn't have dreamed of 10 years ago.
Right. So thank you. And the only other one I had was, you know, we've lost due to this COVID situation we find ourselves in. A lot of the large Noaa research vessels are canceling their huge Bering Sea wide summer survey. So we will be without any information regarding water temperature at depth and sort of the fish compositions and zooplankton amounts and things like that. So I guess we're all going to be keeping a very close eye on the sea surface temperatures as an indication of what may be going on underneath the ocean. And I guess thank you for hopefully keeping us all on top of that with your Facebook site, with what you do here in Nome and elsewhere with the university and whatnot. So thank you, and know that we're very interested in surface temperatures. We have some concerns about that. But anyway, anyone else with questions for Rick? We're coming up, we've passed an hour, so why don't we have one more question?
So Rick, this is Dean Stockwell.
Hi,
Yes,
Dean.
sir.
Great job. Really appreciate it. So
Thanks.
following up on Gay's comment just recently, is there any way with the data collected from PMEL's moorings, Rebecca Woodgate's moorings, that one can model an estimate of bottom sea temperature compared to sea surface temperature estimates? I know the data is sparse, but for HABs, it's very important knowing what that bottom temperature is.
Yeah, and I think the short answer is yes, it's possible to model, and I think it's actually being done. I think the problem is, though, again, the uncertainty in the estimates completely encompass the natural variability. Even counting the last 2 years as part of that variability. So so confidence in the model results, I think would be kind of like sea ice thickness would be low. But it's certainly, I mean, in the absence of observations, you know, maybe that's the best that we can do, but we would have to use it understanding the uncertainty involved there.
Appreciate it. Thanks.
All right, and thanks again, Rick, for your time. And for those in Alaska, what Dean was talking about, HABs, is with increased water temperature in our ocean, there is a thought that we may have the potential for an increase in a uncontrollable growth of some kind of algae. Algae, we need it, but some algae types are difficult for us. They do produce some biotoxins, and there's some concern about whether or not we may have one of those events. So thank you, Dean, for bringing that up, and thank you, Rick.
Is there
And
any,
with
like,
that, oh, go ahead, Claudia. I see you light up. Last
yeah,
question.
I was just wondering if there's any information, like for those of us who are going to roam the land this summer and go hiking, camping, paddling, if there's any information from ground level that might be useful to you that maybe you can't easily get from your, you know, remote sensing kind of thingies that we observe. I don't know. Like,
Is there anything, Rick, that's very kind, Claudia, is there anything that you need from us, especially now that we won't have so much research in the area and we live here? Is there some sorts of information that we can pass along to you, or take data, I guess, do data collection in some ways to help out?
possibly.
Is that what
So
you're asking?
I think that you know, kind of just like we saw last year. You know, I know that, you know, some of the marine scientists have a hard time with this, but you know, last year early on, people, you know, were pulling the pollock up with their crab pots. That tells us something right there about the ocean bottom temperatures, even if it's just in one place in very shallow water. But I think those biological indicators might be the best proxy we have, and especially now that we have some idea of the range of possibilities, that maybe just even if it's back to, oh, we're pulling up what we normally pull up, what we pulled up in our youth, that's probably useful information. both for the biology and it's telling us something about the physical conditions of the ocean.
And this is Gay thank you, Claudia, for bringing that up. For those of us in Nome, if we're talking about sort of marine wildlife issues, do know that you can call me at Sea Grant at Northwest Campus, and that's 434-1149, or Brandon Amosic at Coeric, and his new work cell phone. I have to look at it because with this change in our home office situation, he has a new phone, and that is 434-2951, and that will get you Brandon Amosic as well. With that, thank you, Rick. We're really glad you joined.